Hello, my name is Thomas DM, and I'm going to be talking about the first problem on the Calculus BC FRQ from the 2011 AP test. Basically, what this problem does is it gives us the derivatives of a parametric equation, and it also gives us an initial condition of x of 0 equals 0 and y of 0 equals negative 4. And then it asks us to go through a series of calculations which include speed at a given time, acceleration vectors, slope, position using integrals, and total distance traveled. The good thing about this problem is that everything on it is really straightforward, but there are also a lot of formulas you need to remember to do this FRQ. So if you don't remember these formulas, now would be a good time to pause the video and make sure you know these really well. These are good formulas to know for the AP test or any test on parametric equations. Let's start by solving part A of this problem, which asks us to find the speed and the acceleration vector of the particle at time t equals 3. Really quickly, the speed of any particle at a given time is root dx over dt squared plus dy over dt squared, where t is the given time where you want to find the speed. You can imagine this by thinking of two parametric functions, t of x and t of y, where t of y is the upward-downward movement and t of x is the left-right movement. In the blue graph, you can see the velocity function for x, where the y values are the velocities and the x values are different times. The red graph has y values that represent the up-down movement of the graph. You can then basically use Pythagorean theorem with these two velocities to find the speed at that time. So to solve this problem, you can plug in 3 for each function. When you plug this into the calculator, you get a speed of about 13.007. It's obviously easier to memorize the formula for speed, but it's also helpful to know how it's derived. Part A also asks us to find the acceleration vector at time t equals 3. You might remember that the acceleration vector of a particle is x double prime of t, comma y double prime of t, which is the derivative of the functions that the problem gave us. You can plug in values of t to find the vector at a certain time. Since this question involves the use of a graphing calculator, you can type in each function and make your calculator find the derivative when t is 3. On TI calculators, you can do this by selecting Math and then 8. Your calculator should give you a vector of 4, negative 5.467. The AP scoring rubric gives 1 point for the acceleration vector and 1 point for the speed. In part B, the question asks us to find the slope of the tangent at the time t equals 3. As in other types of graphs, the slope of the tangent line is the derivative at a certain point. A slope is also the rise over run, or y over x. So the formula for slope at the point t equals 3 is y prime of 3 over x prime of 3. Since the problem gives us the values of the derivative at each function, we can plug in the values. We'll get a slope of 0.032. This part of the question is worth 1 point for the correct answer. Part C of this problem asks us to find the position of the function at time t equals 3. Since we know the velocity functions of the parametric equation, we can use integrals to solve this part of the question. Let's start with the known information that the problem gives us. We know that at time t equals 0, the x value of the position is 0 and the y value is negative 4. In order to find the values at t equals 3, we need to integrate the velocity functions, starting at the initial condition. So we take the integral from 0 to 3 of the x and y functions and start at the point that's given to us. The 0 and negative 4 represent the position the particle is starting at, and the integrals are the change in position from time t equals 0 to t equals 3. It's very important to remember that the initial condition isn't always 0, like in the y part of this problem. This is something that a lot of students forget. If we plug this into a calculator, we get the final position of 21, negative 3.226. Going back to the graphs, what we're doing is starting at the initial points, which are the y values, 0 and negative 4. Then we're finding the area under the curve for each function to find how much the position changes. We add these two values together to get our final answer for the position. Overall, this part of the problem is worth 4 points in total, which include the integral and answer for the x-coordinate and the integral and answer for the y-coordinate. The fourth part of this problem asks us to find the total distance that the particle travels over the first 3 seconds. We know that this is an arc length problem because it asks for the total movement of the particle instead of its change in position. The formula for arc length in parametric equations is the integral from a to b of the square root of dx over dt squared plus dy over dt squared, where a and b are the two t values that we are using. You'll notice that this formula has a lot of resemblance to other arc length formulas for different types of equations. Since we are using the times 0 and 3, we can set up our equation as the integral from 0 to 3 of the square root of 4t plus 1 squared plus sine squared of t squared. To find the total distance, we can simply plug this into our calculator. We use Math 9 for TI calculators to find integrals. We'll get a final answer of about 21.091. This part of the FRQ is worth 2 points, one for having the right integral and one for having the right answer. For more practice with problems like these, you can view the links that are in the description. Thanks for watching.